Okay, so as this shape grew, like it's proportional to the new one, meaning if these dimensions are like 1 and 2, and then the scale factor is, let's say, 4, you would multiply these side lengths by 4 to get the side lengths of this. So you're multiplying by 4 times 4 to get 1 times 4 would be 4, and then 2 times 4 would be 8, and you get the dimensions here. So it's related through multiplication, like the side lengths. And then also, if you're told to work backwards and you're told these dimensions and you're working backwards to find scale factor, you can just divide. So you take a corresponding side, like this corresponds to this, and you just 8 divided by 2 equals 4. So the scale factor is 4. And then scale factor, the abbreviation most often used for scale factor is K. So K equals 4, like that. Okay, so that's just tying together concepts that come up in the lesson. We're going to start with these examples right here. It says, use the figure in point C, then use a ruler to draw the image of the figure under a dilation with center C and the scale factor R indicated. We're not going to use a ruler, we'll just freehand it and hope for the best. But the idea is that this here is the scale factor. So this is what the shape is getting larger or smaller by. So the scale factor being 2, meaning this is going to get 2 times as large as the original. And then this point right here is the center of dilation. And this is where it's growing from, which I'll show what that means. Okay, so scale factor of 2. So I mentioned that the side lengths are going to get twice as large, which they will, but also each of these points will get twice the distance from the center of dilation. So this distance right here will double. So I'm just drawing another segment like the same length and putting a new point. And then this length right here will double to get this, that point there. And then this length will double. So this length right here, I'm just going to, as close as I can, draw that same length out from the center. And then these are our new points to our shape after the dilation. So this shape right here, the side lengths are twice as long as the original, and each of these points are twice the distance from the center of dilation. So when your shape is getting larger, it's called an enlargement. Okay, then for number 2, the scale factor is 1/4. So same kind of thing. So this one's going to get smaller by a factor. 1/4 is going to be 1/4 the size of the original, but also the distance from the center of dilation will be 1/4 that distance. So I'm drawing this segment here, and I'm just kind of like eyeballing, like if I broke it in half and then fourths, and then 1/4 would be right here. So my new point is right there. Then I'm going to draw a line from the center to this point on the shape, and just breaking it up in half just visually, and then 1/4 I'd put right there. And then drawing a line to this corner, breaking that up into fourths, putting a point. And then a line here, breaking it up into fourths. I get a point here. Obviously, it might not be perfect because of human error, but here's my new points. Here's my new shape. This is 1/4 the size of this, like all the side lengths are 1/4 the size of this, and this is a reduction. So now these numbers that we wrote down are going to make a little bit more sense. Can you stop talking, please? Now these numbers are going to make a little bit more sense. K is normally scale factor. If K is larger than 1, then it's an enlargement. The shape is getting larger. For congruence transformation, if the shape is staying the same shape and size, the scale factor is just 1, like just 1 times the shape. And then a reduction, if the scale factor is less than 1, for example, here it was 1/4, then our shape got smaller. So examples would be like 1/2, 2/3, 3/4. That would make the shape get smaller. Okay, then over here, we're going to continue the same concept. Same exact type of problem. This time the scale factor is 3/2, or as a decimal, 1.5, however you want to think about it. And so the distance here, this would be 1, and then 1.5 would just be like half of a segment longer. So half of this segment longer would put it here. I'll do that here as well to this. And then half of this segment longer would put it about here, the new point. And then from here to here, half of this segment longer would be maybe about here. So here is our new shape, and this is an enlargement. Okay, and then number 2, it says the scale factor is 2/3. So when we draw these segments, we're going to look for the 2/3 point. So from here to here, if we were breaking this up into thirds, we'd have 1/3 and 2/3, like 1/3, 2/3, like that. So when I'm breaking this up, I'm breaking it up into thirds, and I want to go for the 2/3 spot. Okay, and then this length here, breaking that up into thirds, 2/3 would be right here. This length, 2/3. Then breaking this up into thirds, and then 2/3 would be right here. So my new shape is right here. It is a reduction, meaning the shape's getting smaller. The scale factor is less than 1, it's 2/3, so that makes sense. Moving on over here. Everybody got it? Okay. So the next one, they have it drawn out for us, which is nice. Something we're going to fill in before we get to this, they have us like solving for x, which, okay, so this whole length is 7, this is 5, so this would be 2, this x would be 2. So just fill that in because it's not part of like the concept and I don't want to focus on what x is. Let's see, so 5 and 2, so this x would be equal to 3. Then over here, let's see, 15 minus 10, this x is 5. And then over here, 1 plus 2, this x is 3. So just fill that in so that way we don't have to focus on that throughout the problem. Okay, so for this problem, it says, determine whether the dilation from figure k to k prime is an enlargement or reduction, then find the scale factor of the dilation and x. Okay, so k to k prime is how it's moving. K prime is always the new, and then k is the original. So here, k prime is larger than k, so this is an enlargement. And then the next thing it asks is about scale factor. So scale factor is new over the original, or k prime over k. And you can choose a dimension, whether it be a corresponding side or it could be the distance from the center of dilation, and you can make that fraction and divide it. So k prime, the distance from the center of dilation, is 7, and then k is 2. So the scale factor is 7/2 or 3.5, however you want to think about it, whether you want to think about it as a decimal or a fraction. And so 3.5. So this shape is 3.5 times larger than this. Okay, the next one, so from k to k prime, it is actually getting smaller. So this is a reduction. For scale factor, k prime over k, the new over the original, The distance to k prime is 2, and then to the original is 5. So our scale factor is 2/5 or 0.4. Okay, we are going to continue. Same concept with number 3. Again, it's going from k to k prime. So k to k prime is getting larger, so this is an enlargement. For a scale factor, it's new over the original. So k prime is 15, and then to k is 5, so the scale factor is 3. So this is 3 times as large as this. Something else I made on my notes is not only could you use the distance here to find the scale factor, but you could also use a corresponding side length. So let's say they said that this is 18 and this is 6 centimeters, inches, it doesn't matter. But you can always put new over the original. So for a scale factor, you could do 18 over 6 to get 3 and find the scale factor that way. Okay, and then number 4 here, from k to k prime, okay, it's getting larger, so it's an enlargement. For a scale factor, new over the original, so we'll do to k prime is 3, the original was 2 away, so 3/2 is our scale factor, or 1.5 as a decimal, same thing.
Where are you getting the numbers?
The length from the center of dilation. Yeah. So yeah, this was 3 units away, and then this was 2 units, so I put 3 over 2. Then we're not going to do these two because they don't fit the graph very well. But we're going to go over here and do these. Okay, so now it's bringing in like coordinates and how this will look on the graph. So we're going to start just by graphing these points, and then the scale factor is 2, and we'll get to that in a second. So first of all, I'm going to graph these coordinates here. J is at 2, 4, 1, 2, 3, 4. J. K is at 4, 4. And P is at 3, 2. Here's our shape. Okay, so for these, the dilation is centered at the origin. And for most of the problems we do in high school geometry, the dilation is centered at the origin. So that is your center of dilation. Center of dilation is the origin. So to dilate this shape by a scale factor of 2, we're going to get each of these points twice as far away from that in that same direction. So J, it is, you can go over 2, up 1, 2, 3, 4. So to get J prime, I can go over 2, up 1, 2, 3, 4. And then this is J prime. And then for P right here, from the center, I'm going over 3, up 2, so I can go over 3, up 2 again to get P prime. And then for K, this length here, it looks like I'm going over 4, up 4, so I can go over 4, 1, 2, 3, 4, up 1, 2, 3, 4 to get K prime. And then this shape, all these points are twice the distance from the origin, and also these side lengths are twice as big as in this triangle. However, there is another way that we can do this when it's centered at the origin. And I want to show you that way too, because it's a little bit easier to use than trying to figure this out. So just make a note on the side. I'll use a different color. Okay, note on the side. When dilating from the origin, you can multiply the coordinates by the scale factor to figure it out. I think that says scale factor. What does that mean? It means that you can take this scale factor and to find J prime, K prime, and P prime, you can just multiply 2 times those numbers to get the new coordinates. So for J prime, I can do 2 times this would be 4 and 8. K prime would be 8, like I'm just multiplying these by 2. And then for P prime, I would get 6, 4. Again, I just multiplied those by 2. And then these coordinates should be the same thing that I graphed and figured out. So over 4 up 8, yep, J prime, 8, 8, K prime, and then 6, 4, P prime, like that. Yes.
Did you do this with the reductions as well?
Yes. Yes, it works a lot. Yeah, it works really well. This is actually the primary way of doing it, but I wanted to make sure you understood the concept as well. Okay, so then for number 6, our scale factor is 1.5. We're going to graph these original, then we will multiply all these numbers by 1.5 to find the new coordinates. Okay, so graphing the originals at -2, 0, D, 0, 2, G, and F is at 2, -2. Those are original points. Center of dilation is the origin. And so our scale factor is 1.5, so all these points are going to get 1.5 times away from the origin. Let's see. So we can multiply all of these by 1.5. 2 times 1.5 is 3. So this would be -3, 0, 0, 3. And then 1.5 times 2 here would be 3. 1.5 times -2, -3. And then we graph these points. So -3, 0, D prime, 0, 3, G prime, and 3, -3. Here are our new points. The shape is 1.5 times larger, and all the points are 1.5 times further from the origin. Okay, next over here, we're just going to do number 7 and then we are done. Okay, so number 7, it says estimate enlarge a 4 by 6 inch photograph by a factor of 5 halves. What are the new dimensions of the photographs? I'm going to draw a picture so we can all see it. So we have a photograph like this. It is 4 inches by 6 inches. We enlarge, it says enlarge the photograph by a factor of 5 halves. So I'm going to draw a larger version, and we need to figure out the dimensions of this. So we can take the dimensions here, 4 inches, and times by the scale factor to get the new dimensions. 6 inches times 5 over 2. You could do it in a calculator or just the old-fashioned way, put fraction over 1 and multiply across. We get 20 over 2, or 10 inches. And then this over 1 would be 30 over 2, which is 15 inches. So we get 10 inches by 15 inches. And then also I wanted to show it to backwards too, because it comes up on the homework, and just so you know, if you were given the dimensions of this and you were asked to solve it backwards to find the scale factor, its scale factor is new over the original. So like this is the new one, this is the original. So you choose a corresponding side. So if you wanted to choose this corresponds with this, and you can just put 15 over 6 and then just simplify it to find the scale factors. Divide by 3, I get 5 over 2, which is what I started with. So that's how you do it. Okay, that's his app. So what you're going to do is, if you haven't been absent, you're not missing any pages. We did skip one lesson in there, so if you see that, that's why. Turn in your packet and then log on and do the homework on Schoology and then work on Alex. If you have questions, let me know. Yes. Yes, you may.